Alright, so for number 9, we just need to sketch a curve, or select the correct curve with a given polar equation. So our equation here is r equals 5 minus 4 cosine theta. So the brute force method of doing this problem would just be to go through a variety of thetas and plot points, which would certainly work, and you could probably get the right answer from that. A little bit quicker is if you just know the forms of these polar equations and what these are going to look like. So I'm going to go through that way. So since we have the form, the general form being a plus b, let's do a plus or minus b cosine theta. You know that this is going to be a cardioid. So remember, the cardioids are the things that kind of look like circles but that have bumps in them and potentially loops. So let's think about what it means for particular values of a and b, and the fact that we had cosine. Because remember, a cardioid could also be plus or minus sine theta. We have the cosine one. So that the fact that our function is cosine tells you that this cardioid is horizontally oriented. So it's going to look like the big side is either over here or it's over here, but it's going to be directed along the x-axis because we have cosine. The next thing we want to think about is we have a minus sign here. So having a plus or minus sign changes something. That tells you is the big side of the cardioid on the positive part of the x-axis, or is it on the negative part of the x-axis? This time we have negative, so we know that the large part of the cardioid is going to be on the left. And then we just need to consider the numbers. So you can have a loop if the number attached to the cosine is bigger than the number that's by itself. We don't have that here, so we will not have a loop. And furthermore, it would only touch the origin if this number was equal to that number, or smaller, and have a loop. So this function is a horizontally oriented cardioid. The big side is to the left part of the x-axis, the negative part of the x-axis if you think about it in Cartesian. And this function does not touch the origin at all. So the last thing you want to do is just let's plot some basic points. The easiest ones to do are the points that are on the x-axis. So in this case, if we plug in 0 for theta, we're always going to get the difference of these two numbers, which is a radius of 1. The sum of these two numbers is going to be the biggest part of the cardioid, which is going to be 9. So now we just need to draw a basic shape. It's going to come in like this. It's going to have a little bump here at 1. And it's going to go all the way out to 9. So once more, let me run through this real quick just so you can get some major points on here. The difference between those two numbers is always the smallest part, or if the number in here on this one was bigger, then you'd have a loop and its size would be the difference between those two. The sum of those two numbers is always the biggest part of the cardioid. So those two things that I just said, the difference and sum, giving you the extreme values, that's true whether this is minus or plus. Remember, the minus or plus just changes that it would have been on this side instead of that side. Lastly, two other points if you were given this on like a free response and you needed to show some points. Where does it cross the y-axis up here? What are its pi over 2 and 3 pi over 2 values? Well, since we have cosine, that's going to be when this is 0. So these are just going to be 5 and negative 5. And this was 1 over here. So those are all the key points of that graph. And you can, like I said, I got all that information just by thinking about the standard formula. So cosine, horizontally oriented cardioid. B is smaller than A, tells us there's no loop and it doesn't touch the origin at all. Since it's negative, we have it oriented to the left, and getting all the key points, you can just either disregard this. If the cosine part is 0, that gives you the vertical ones. The difference gives you the short side, the sum gives you the long side.